Okay, so let's assume that you're going to pick for this to not be a linear model in this first section. We're going to say that that's still our polynomial section, but we're going to just be saying that, you want it to be some power higher than 1. If it is a linear model, I'm expecting to see that you've done the calculations to determine what that equation is. Otherwise, here's your other option. So we've worked out that the domain of this is between 0 and 6, meaning that these pieces of data from 0 to 6, that data is what we want to be using to fit a polynomial model to. So I copy this, Control-C, I go to eLearn, and I punch it in with Control-V. So you can see here now that I've got that data appearing. So now the next thing that I want to do is go down below, and I'm going to get it to fit to the data. Now, the assignment is not about fitting data, so we don't need to really comment about the regression scores. We don't need to find the regression scores of your other functions. This is just for if you want to get it to fit some data. So you get it to pick that range. Now, we want it to relate back to only this part of the data set. So I'm going to be using Y3. So Y3, our fun little regression symbol. So you get to press Shift and then the button that's next to the one that looks like that. Now I can start entering in polynomials. So if I wanted it to be a quadratic, then that would be AX. Remember, tell it which X it's looking at. To the power of 2 plus BX plus C. So now it's given me this. You can see over here how it's fitting the data. You can see how well it's fitting the data. And now we can type out what that is as a number. So really the equation that this generates for us is y equals A is 932.143 x squared plus negative 15132.1 x plus 132,779. Okay, and that will fit to that section. Now, if I want to show this as a piecewise function, so I only want it to graph that little bit, all I need to do is put the bracket around it here, and I tell it what domain to go in between. So it's going to go from 0 up to and including values of x where it is 6. Okay, and then the semicolon, that little one there, we'll get it to graph only that point. So now I'm going to close that bracket. Now you can see if I turn off the fitted model, now it's only graphing between here and here. So if I wanted to turn that off as well, now I could see what it's going to look like as just the basic model there. So I've got my first section, my polynomial done. If you think that your section that's going to be a polynomial looks more like a cubic, then you would use the cubic equation here. If you think it looks more like a quartic, then you'd use quartic here. You can really go as high as you want, but again, the assignment is not about making this r squared value as close to 1 as possible. This assignment is about using calculus to work out the rates of change. So we need functions to be able to do that. These are the functions that have been generated by this equation.